In this video, we will be simplifying expressions using two different methods. The first one is a review of the method you learned yesterday, which is called the distributive property. And the second method is the new method for today. So again, we're going to start off by reviewing the distributive property. It's very important that we understand why this works and how it works. Because in order for us to use something, we got to understand it. So here we have an expression. The directions are usually always going to say simplify using the distributive property or just the word simplify. That's how you know all you're going to do is rewrite the expression. You're not actually going to solve it because that question did come up yesterday. So in this case, this whole expression, y plus 3, is being multiplied by this one number, the 5. So that means every part of the inside is going to be multiplied by the 5. So that means 5 times y, and then 5 times 3. And we skipped this step yesterday, but technically, some people show their work distributive property by doing this. 5 times y, and then 5 times 3. Some people write the expression like that, like, hey, I'm going to do this multiplication. Now, while that does help us visualize, I feel like it's actually unnecessary. So this is the one time I'm going to say, maybe you can skip this work. Just draw the lines to show me that you're multiplying. And then 5 times 3 and 5 times y, we should know the answer to. The thing I did want to elaborate on, because I kind of just told you without explaining this yesterday, because yesterday the big idea was distributive property, is why this 5 times y becomes 5y. So I'm going to take a minute here to describe this. Since the y is by itself, it's ay. If you analyze that a little bit further, ay is a singular y. A singular y means there's one y here. There's just one y. So one y is actually the same thing as just a y by itself. In math, again, you guys hear me tell you this all the time. Mathematicians are lazy. They're lazy. They don't think it's necessary to always have that one. They're like, no, well, people should assume that when we have a single y, that means one y. So this is like sometimes people refer to it as invisible math. There's an invisible number here that's there. You need to know it's there, but it's not actually going to be there. So it's pretty tricky in the long run. Ay is the same thing or equal to 1y. So when we do 5 times y, we're actually doing 5 times 1y. And when you multiply this, you're actually multiplying 5 times the coefficient, which is the 1. 5 times 1, this happens to be 5. And then you finish it off, and then 5 times 3 is 15. And that's how we simplify the expression. And that's why, like yesterday, in every class, we got to a problem where I changed this from a 1 to like a 3 or a 4, and you guys were still 5 times 4. Because when you multiply a constant with a variable term, all you're multiplying is the number with the coefficient. There's an invisible 1 here that we don't necessarily always need to have there. A lot of good information here. Now so this is how the distributive property works. Let's see why it works. So this seems a little overwhelming. I'm going to explain every bit in piece. So this is the same problem. So back when we were in kindergarten, we started learning math by using pictures. So my triangles are my y's, and then the 3 is the plus 3. So I have this 5 times 5 different rows. 1, 2, 3, 4, 5. So I drew this math out, and then the last step would be, all right, let's count all the triangles. 1, 2, 3, 4, 5. 5 triangles, 5 y's. Let's count the blue circles. 1, 2, 3, 6, 9, 12, 15. 15 blue circles. You can't actually combine. You can't actually combine triangles and circles. So you got to keep it together with a plus sign, but you cannot add it. It does not become 20y. I repeat, you cannot combine these. So this is the very basic, simplest form of math, pictures. Now, is this the most convenient? Not necessarily. We don't want to, especially as these numbers get bigger. Imagine if this was 28. I don't want to draw 28 groups of anything. Drawing 5 groups of this was kind of bothersome. And then we took it a step further. We said, well, let's learn how to add. So I wrote this expression, y plus 3 5 times. 1, 2, 3, 4, 5. This time I wrote it vertically. That way we can see, I can add all these y's. That gets me my 5y. And then I can add all these 3's. And that's how I get 15. But again, this is a little bit more work than the distributive property. Yes, can you use it? Yes. Is it going to take a little bit longer? Yes. Is it going to take super long when we make this like a 28 or something? Definitely. And that's why we need the shorter method. And that's where we get to the distributive property. You distribute the 5, which means everything inside gets multiplied by the 5. 5 times 1y. That's 5y. 5 times 3. That's 15. So if I could do this, the drawing, this, the addition, or this, I'd rather do this. This takes me like 10 seconds as you saw in class. We got through quite a few practice problems at the end. This is our go-to method. It is still good to know this though. That's why I'm reviewing this and showing it to you multiple times. This is super good to know that you can draw algebra, or you can write distributive property or multiplication in algebra like this. All right, we're done with distributive property for today. So that's one way you can simplify an expression. There's actually another way you can simplify an expression, and that's what you're learning now. In algebra, we're going to get expressions that look like this. 6h plus 8h plus 9 plus 37. Now, at this point, we would ask ourselves, well, what do we notice? Like, for sure, right away, I think we all notice we can combine 9 and 37, right? They're both constants, so that means we can add that. That would make it look simpler. So why don't we do that? 9 plus 37, 46. But then here you have to think, like, hey, I could probably do the same thing here. Because they're essentially the same term. If I have 6 h's and I add 8 more h's, that means in total I would have 14 h's. And I'm done. You see how this expression was a little bit longer up here? Now it's simpler. I got it down to 2 terms, 1, 2. This method is actually pretty out there. It's called combining like combining things that are like each other. So in this case, regular numbers or constants with other regular numbers. Things that have the same variable with each other. And this you can actually draw too. If you really wanted to, you can draw out the very beginning. So let's say this is H. One, two, three, 4, 5, 6. And then I need 8 more. And then this is where I'm getting to, that sometimes drawing these things out is not actually feasible, because I just realized that I'm going to need 37 of something, and that doesn't really make sense. So plus, and then I'll do plus 9 and plus 37. I'll cheat. I don't want to draw this out because that's going to take a very long time. Let's say that this was 9 circles and 37 circles. Dot, 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 dot. So you would be able to combine all these circles because they belong together, and you're going to get 46 circles, which is what we have up here. And then you would combine all the diamonds because they all belong together as one, and you would get 14 diamonds, or 14 each. So you're taking something that has like groups that are separated but belong together, and you're actually putting them together. That's what combining like terms is. Let's practice on another one. So in the last one, this was pretty easy. Things were next to each other. It was in order, but we're gonna get very hard very quickly. So this is still combining like terms, but now things are out of order. So this is where you saw me use the highlighter here. You, we highly, highly, highly recommend using a highlighter for these problems. Always highlight, like let's say I see that there's an A term. I'm gonna highlight the A terms in green. Go down, and notice that I'm highlighting the signs that are in front of them. Alright, then I'm going to highlight the constant in blue. That's the only constant. And then I'm going to highlight the x terms in red. So in green, I have 3a minus 2a. Because I'm putting these together, they belong together. Notice that I'm bringing the subtraction sign. These things travel with the signs in front of them. 3a minus 2a. Well, if I have 3 A's and I lose 2 A's, that means I have 1 A, or an A, singular. Let's do the X's. Again, I'm bringing the plus sign in front of the X. Not really needed for this one. Plus X literally just means 1X, positive X. If I have 1X and I add 7 more X's, that means I have 8 X's now. And then the last thing is the plus 5. That's not being combined with anything. So this is my simplified expression. I got it from 5 different terms to 3 terms. And this would be A plus X plus 5. And this is the final answer. Next one. All right, we have n terms, we have p terms, and then we have constants again. So let me start by highlighting in blue. I'm gonna do the n terms, so 5n, and then the 3n with the subtraction sign. Green, I'll do the constants. So in this case, just seems to be the 5. Oh, I'm having Wi-Fi issues. Okay. I don't know what just happened, but I had a little Wi-Fi malfunction. So it might seem like I cut in or out of the video and then back in. But we're gonna get a fresh start on this problem. So I was highlighting the different like terms in different colors as I always do. So any n terms I'm gonna highlight in green. Again, bringing the signs in front of them with them. So notice that it has a subtraction sign, so I'm bringing that with it. I'm gonna do the constant in blue, and then I'll do the p terms in yellow. And then I'm gonna just put these things together. So I'm gonna start with the n terms. 5n minus 3n. Well, if I have 5 n's and I lose 3 of them, that means I have 2 n's. Now I'm gonna do the p terms. P terms are in yellow, so plus 3p plus 10p. If I had 3 p's and I add 10 p's, that means I now have 13 p's. And the last thing is the constant, but that's not being combined with anything, so that just stays a plus 5. So my simplified expression is 2n plus 13p plus 5. That's my simplified expression. I was able to combine 4 of them. These two and these two. Alright, so that's basically combining like terms. Just as a little challenge and just to kind of bring in some review. I like these problems, but a little bit of geometry mixed in with algebra. Find the perimeter of the figure. So perimeter means the outside. So if I walk around this triangle, how far did I walk? You are going to see this. You're like, this doesn't make sense. There's an expression as a side. This is actually pretty common in algebra. The two math forms, geometry and algebra, get intertwined repeatedly. But so as you notice, as I trace, so basically, if I'm walking this whole distance, that means I have to add this plus this side plus this side. So down here, x plus 14 plus x plus 14 plus 2x plus 36. So again, I'm going to go through, highlight all my x terms in blue. And I'll highlight all my constants in green. Combine the like terms. X plus x plus 2x. Well, if I have one x and I add another x, that's 2 x's, and then I add 2 more x's, so that's 4x. And then I have plus 14 plus 14 plus 36. 14 and 14 is 28. 28 and 36 would be 64. This is what we would call a perimeter. Let me actually take a step back. P equals, the perimeter is 4x plus 64. And that's combining like terms. Just combining things that are like each other. Hopefully, it's as easy as distributive property, which you guys, majority of you said this is pretty easy. Those are the two ways you can simplify an expression: combining like terms and distributive property. Tomorrow and Friday, we're gonna just have some practice with this stuff. Pull out the whiteboards, try to incorporate a game. The good thing I like about algebra is all these problems are super easy, super quick. So you can actually play games with these problems. It's not like word problems or unit rate where you have to actually talk about the word problem and all that. Algebra is pretty quick and easy. Lots of games we can incorporate. So I'm hoping to incorporate those over the next few weeks. You should have already finished a warm up for today. Should have finished this on your own before you watch this video. Now that you're done with the video, you're supposed to complete this independent assignment. Combining like terms, so it's just practice of what I did. I do want to see the highlighting. I want to see everything your work. Don't just write an answer. And then there is some challenge ones at the end. Find the perimeter of the figure. But it's basically combining like terms. All right. And if you have any questions, feel free to contact me. If you do finish this assignment, I did assign some things on Khan Academy. It's basically one activity on combining like terms, one activity on distributive property. And if that's not finished today, there's a chance it might be worked on tomorrow. All right. Hope you guys are all good. Have a good day. Let me know if you have any questions. We'll review all of this tomorrow again. Very important.